Alright, I managed to shorten the drill. You can see there isn't a lot of space here. So, here we go. We're going to drill and then tap, and we should be good. Operative word is should be. Here we go. Wish us luck. All right. 15 minutes of work to do 45-second drill. That's always the way, isn't it? Like welding, 90% prep, 10% weld. All right. Well, let's get this bugger out of here. There you go. All right. Yeah, I know some of you are going to be upset because I'm tapping with a drill chuck, but it's aluminum, my shop, my rules, my tools, so this should be all right. If it's not, I get to fix it. All right, I'm going to put a little bit of this stuff. This is Tap Magic. Look at that. Okay. All right, let's slow this thing down. No speed tapping today. At least not on this, right? Okay. That's as slow as she goes, everyone. So, here we go. I'm looking for it to poke out the bottom. I don't know if I have enough hands. She's self-tapping now. That's it. The hole is in. Alright, let's see how that stud screws in. And we have one more operation to go. A little counter bore for this. And we'll be in Fat City. Wherever that is, we'll be in it. Alright. Look at that. Make that good for the next guy. Oh, that's me. All right. Let's see. Here is a stud. Drum roll. Here we go. That's not bad. Trouble is, I don't remember which one of these belongs to this thing. I don't know if it's this one or this one. Maybe this one. Seems like it needs to stick up quite a bit. Get the cylinder on there. Not sure. I had one stud with it. Alright, well that's done. Let's see if we can get set up to bore that hole. We're going to have to sneak up on it. Quoting Keith Fenner again. It's a great term. Quick change out. Sorry about that compressor. It's kind of a necessary evil in the shop, as you all know. Alright, we're going to go with this one because you need to reach down in there and not bottom. Let's see, it's pretty good. Fortunately, this is always an eyeball deal to get that cutting edge kind of on the plane of the center. So when you set this, it's where it needs to be. Those deals. So we don't need to go much. All right, let me get my ball mic. Here's some here. Not a ball mic, telescopic one. A ball mic on the brain for some reason. And I think I'll get caliper will be fine for what we're doing. Just has to make that dowel fit. Let's see where we are. Probably around 499 or possibly a whisker over 500, but let's find out. That other hole is 511. That's what we're shooting for. So, no, that can't be right. This thing says it's 512. In a way, it's 512. All right, let's see what we got going on here. Definitely bigger than that one. If that's the case, the dowel ought to go right in, which it doesn't. Okay, 510. This thing, it's kind of, I don't know if you can see this here, but this is a rolled piece. There's a split line right there. You can look, if I light up that bore, you can see it. See that split line? That's a rolled piece. It's not a piece of tubing. It's a rolled thing. Anyway, so it's not really round. It's larger this way than it is that way. So it just has to kind of be there. And I'm not feeling it there. I don't know why that thing says it's so big and it isn't. Obviously, it's operator error. So let's see if we can fix that. Let's find out where it is. That's more like it. 505. So we need to shoot for like 5 and some change, and we've got to be in the money here. So let's get that bar set, light this pup up, and get the job doing. All right, we're gonna need room to turn this. Neutral. Wow, it's still a ways off. There we go. There. It's going to have to be our 0. This is going to be 0. Whatever 0 is. So, all right. I'm going to have to follow the 430 number again, more or less. I guess we can just wait to hit the bottom, which, fortunately, my fine feed does not work at the moment because the wheel's gone. So, I think I'm going to feed it with the table. Pick this up. And back in here. And I think we'll go with that now. Almost there. Just have to listen. All right, that's where we are. Okay. Snap gauge. See what our condition's in here. Anyone remember that song? See what condition my condition is in? Well, that would be playing right now if I was able to do it. All right, let's see what we have. 509. 509. So we need to put 2 on it. I don't trust this thing, so we're going to sneak up on it. Right, let's try that and see how we do. I'm going to go crazy and see if I can slow feed this thing myself and not tear the hole all to pieces. We're going to go with it. Here we go. I don't know if I really like doing that. It doesn't seem tight enough. Alright, let's see what that is. Says we're on the number. Alright. Drum roll, I guess. Alright. Well, better too small than too big, you know. You make just a whisker of an adjustment. We'll make another pass through there, and that'll be probably be good. All right. You have to remember, when you take a thousandth, you're taking a half a thousandth out of each side for a thousandth total. That's why sometimes you kind of skim down through there and kind of, I probably ought to speed it up. I don't want to take the chance of running into the bottom and digging the boring bar into the, digging it into the bottom of the hole. And so I think we'll go with what we have. This time I'm going to table feed. Getting too old for this. I need to put that power feed on. Anyway, here we go. Oh, it seems like such a long way when you do it this way. It's only 430 thousandths, 10 millimeters. Should be hearing that thing hitting the bottom here in a second. Huh. There we are. Oh. Okay. Are we on it yet? Let's find out. Should have been just about enough to be measurable. Now it says it's 512. And it's bigger this way than it is this way by a little bit. That's kind of inevitable from all the welding. That doggone thing just doesn't want to go in there, does it? I'm going to have to skim it out of there. It's coming out of this side right here where the weld was, because I picked the hole up off of, I set my zeros before the case was milled and put it back on the DRO, and I mounted the plate back in the 90-degree plate. But from the welding and this, it was subject to me mounting it back, obviously, getting this and this back in the exact same spot. So I had traced this plate around the 90 to relocate it, and then I could verify off this edge that it was on, and it was within like 4/10 according to what I had to mark it and do it with up the center. So I had a measurement from center to here, and it was on it, but small error, stack on tolerance sometimes can cause issues. So, all right, we're going to take another little cut out of there. Just need to get that dowel to work. A little bit. All right, that's a little bit. All right, here we go. No, That's not taking anything. Huh. That's not taking anything. I'll be doggone. Oh. Alright, let's see if we can get this a little better. I don't like to loosen these locks too much. This isn't a really high quality boring head. And I don't like to really over tighten them either because it's not a really high quality boring head. So I kind of just do it like you do with carbide inserts. Just use this like that. Not the long, don't use the long lever to really force them because it's a little tiny screws, like 3mm, I guess. So, alright, this is going to do it, I think. Dive in, see where we end up. That's better. Should hit bottom pretty quick. And here we are. All right. Okay. Really needs to be, at least a lot of it. God darn. That thing doesn't want to go in there. I don't know what the deal is. That's perplexing. It wants to go in. I think I just need to speed this thing up so I get a cleaner cut. Of course, that welding wire is 4043, and that's what you want to use on this die-cast Japanese genuine imitation aluminum. Unfortunately, they have a tendency to put a lot of silicone in it. And not only that, they also, and this is just me guessing, but from welding numerous castings over the years, I've kind of drawn a conclusion that they must use lead or zinc as some sort of an extender or some sort of a glowing agent or something to get to get the dies to fill completely, to get nice castings. But sometimes welding that stuff is like trying to weld wheel weights. You never know. You may weld 5 of these and 3 weld nice and 2 hard. There just isn't any rhyme or reason, it seems, to what they were using back then. Of course, this thing is, let's see, my math sucks right now. It's a 1980 or 79, so what's that, 40 years old? So, that's out there. A lot of stuff's changed since then. But anyway, let's see if we can take a same pass down through, but we're going to speed things up a little bit. Okay. always seems like such a long way, doesn't it? All right. Okay, let's see what that gets us. Excuse me. All right. This is one of those times when I wish I had a a turret spacer in this machine. I've been threatening to make one, and I think I need to make one because this is the old style turret, and the spacers aren't real common. I thought I found one, and I lost track of the guy. Maybe I need to go on one of the boards, one of the groups on Facebook, one of the machine groups, and find a round ram turret spacer. Some of them call them risers. They're called turret risers. But need more spindle to table clearance. You can always make them taller, you know, to get more room, and then you can build up to it. But once it's too small, like just too small. So, all right. That doggone thing just isn't interested. No, it does not want to go in there. Almost wants to go in there. Guess I'm going to have to take another skim cut. It's alright, we'll just stay with it. It'll be alright. We'll get it. I guess at this point, measuring is kind of a nebulous thing, because basically we're cutting it to fit. And as much as you'd like to depend on the measurements, those telescope gauges are better the bigger the hole.